So guys, coming to the next topic, the heme catabolism or the bilirubin metabolism. Topic for the day is heme catabolism or the bilirubin metabolism. Basically, the heme is catabolized into bilirubin, and then we'll be studying about the bilirubin metabolism. First of all, where it takes place, since it is a catabolic pathway, it takes place in the reticuloendothelial system, that is the spleen, liver, bone marrow. Reticuloendothelial system, spleen, liver, and the bone marrow. The degradation takes place in here. Basically, these are macrophages, the cell-eating cells. What actually happens in the macrophages is hemoglobin. The hemoglobin, the globin molecule is removed, which is then converted into amino acid and used further, and the heme is removed. The heme is first converted into biliverdin. The biliverdin is then converted into bilirubin. Bilirubin is unconjugated here. With the help of albumin, it forms the albumin bilirubin complex. Which is finally given to liver. The liver में it will be going to liver, the albumin bilirubin complex. So heme, what actually happens on heme is acting NADPH and molecular oxygen. NADPH and molecular oxygen, here endogenous production of carbon monoxide is taking place. This carbon monoxide is produced endogenously, and the enzyme that is required here is heme oxygenase, which is present in the microsomes. Heme oxygenase is present in microsome, and here Fe+3 is also removed. What molecular oxygen does is it breaks the methynyl bridges, alpha methynyl bridges. O2 basically acts on the alpha methynyl bridges to form the linear pyrrole biliverdin. This biliverdin is a linear pyrrole and is of green color. Linear pyrrole, green colored biliverdin is formed. Biliverdin पे acts the biliverdin reductase, which is present in the cytosol. This was present in microsome, but biliverdin reductase is present in the cytosol. The biliverdin reductase is present in cytosol, and it's converted to yellow-colored unconjugated bilirubin. Basically, here the biliverdin reductase breaks these again methynyl bridges to methylene bridges. The methynyl bridges is converted to methylene bridges. And bilirubin yellow color. Now this bilirubin is toxic, insoluble in plasma, but ये lipid soluble है. So it has to be transported to liver with the help of albumin. It helps to carry bilirubin to liver via the blood. By forming the albumin bilirubin complex. Now this albumin, it has a high affinity end and low affinity end. If you talk about the albumin, to 80 to 90% maximum, it has high albumin, it has high affinity site, and we have some low affinity site. This high affinity site, 25 milligram of bilirubin binds to this, and remaining rest binds to this. 1 gram of hemoglobin has 35 milligram bilirubin. Okay, so this is all about this. How it is the unconjugated bilirubin is now reached to here. Unconjugated bilirubin is now in the liver. What happens if we see once again hemoglobin? It gets globin and amino acid is removed. Heme is formed. Heme, NADPH and molecular oxygen is acting here. NADPH and molecular oxygen acts to form the biliverdin, the linear polymer, which is a green color. Methynyl bridges पे O2 acts and endogenous production of carbon monoxide take place. Now, biliverdin converted to unconjugated bilirubin with the help of biliverdin reductase, which is present in cytosol. Now, unconjugated bilirubin is yellow colored, is toxic, and it cannot be transported. Albumin helps in its transportation. To albumin bilirubin complex is finally taken to liver. Now, in the liver, the bilirubin metabolism takes place. Now, how does bilirubin metabolism takes place in the liver? So, we'll be studying the bilirubin metabolism. Okay, bilirubin metabolism. Basically, we have three steps in the bilirubin metabolism. These are step number 1, number 2, and step number 3. Uptake of unconjugated bilirubin. Uptake of bilirubin, which is actually unconjugated in the liver cells, that is the hepatocytes, first step. The second one is the conjugation occurs. The unconjugated bilirubin is converted to conjugated bilirubin. And in the third one, it is excreted, yes, secretion onto bile canaliculi. Secretion occurs into the bile canaliculi. Secretion occurs into bile canaliculi. So if we talk about the uptake of bilirubin in the hepatocytes, how does it occur? The albumin bilirubin complex, first one, uptake. How does this uptake occurs? Suppose this is the blood vessels, blood walls है ये, ठीक है, and this is the hepatocytes. ये हमारे क्या है? Hepatocytes. ये हमारे hepatocytes हैं. So what actually happens is the albumin bilirubin complex, albumin is released into the blood, and the bilirubin is unconjugated bilirubin is pushed into the hepatocytes by the help of facilitated diffusion. ये कौन सा diffusion है guys? This is facilitated diffusion, and this facilitated diffusion is rate limiting नहीं है, लार्ज कैपेसिटी, मतलब जितना आएगा इट लेता जाएगा अंदर, ठीक है. Here to intracellular protein, ligandine and protein Y are present in the hepatocytes, which basically has two roles. इसमें दो रोल क्या है? It prevents efflux of bilirubin, and the second one is it keeps the bilirubin in solubilized state. Keeps bilirubin in solubilized state. Okay, it keeps the bilirubin in solubilized state. Now, this bilirubin is being uptaken by the hepatocytes. The second step is the conjugation. Now, how does the conjugation takes place? Basically, the unconjugated bilirubin, what actually happens is unconjugated bilirubin acts the UDP, glucuronide transferase. Glucuronide transferase. UDP glucuronide transferase, इस पे लगेगा UDP glucuronate. पे लगेगा UDP glucuronate. UDP glucuronate converts it into bilirubin monoglucuronate, and again the same enzyme UDP glucuronyl transferase acts on it to form again one molecule of UDP glucuronate to form the conjugated bilirubin, the bilirubin diglucuronate. Now this is a conjugated bilirubin. ये conjugated bilirubin है. Now, this conjugated bilirubin has basically mainly conjugated bilirubin. It is secreted into bile. Bile में secrete होगा first one. Some part via the multi-drug resistant protein 3 is transported back into the enterohepatic circulation and some part via the organic anion transport protein 1A1 and organic anion transport protein 1A3 is reuptake by the hepatocytes. Secreted into the bile, and it enters the intestine then. So basically, what happens in conjugation is unconjugated bilirubin. Same enzyme acts 2 times UDP glucuronide transferase to form once a monoglucuronate and then a diglucuronate. This diglucuronate is only the conjugated form. Now, this conjugated bilirubin is now secreted into the bile and then into the intestine. Some part by the multidrug resistant protein 3 enters into the enterohepatic circulation, and by the organic anion transport protein 1A1 and organic anion transport protein 1B3 it is reuptaken by the hepatocytes. The last or the third step is the secretion into the bile is an active transport. Secretion, it is an active transport, it is a rate limiting step. यही rate limiting step है, यहीं पे control होता है. It is a rate limiting step. Active transport via multi-drug resistant protein 2, MRP2. होता क्या है basically कि the conjugated bilirubin is actively secreted via the MRP2 into the bile. Now ये bile से तुम्हारा ileum and colon में जाएगा, into the intestine में जाएगा, and then it is forming the urobilinogen. 90% of urobilinogen is converted to stercobilinogen, which is forming the stercobilin. Now this stercobilin is responsible for the brown color in the feces में यही brown कर देता है, and some part of urobilinogen is converted to urobilin, which is providing the yellow color in urine. ठीक है, 90% stercobilinogen में चला जाता है. Now, some disorders related to it. Now, this enzyme UDP glucuronide transferase, if it has the partial If we have the partial absence, then it occurs the Crigler-Najjar syndrome too. Partial अगर absence इसका है, then we have the Crigler-Najjar 2. And if we have the complete absence अगर इसका हमारे पास क्या है, completely it is absent, then occurs the Crigler-Najjar 1. If this is absent, OTPA, organic anion transport protein, इसमें अगर है तो we have the rotor syndrome, direct hyperbilirubinemia, and if we have MRP2 resistant mutation, we have Dubin-Johnson syndrome. We want Dubin-Johnson syndrome. So this was about the heme catabolism or the bilirubin metabolism. What happens? It occurs in the reticuloendothelial system. The heme catabolism occurs in the reticuloendothelial system. Spleen, liver and the bone marrow. Hemoglobin, heme बनेगा पहले with the help of heme oxygenase जो कि microsome में present है. NADPH and O2X, Fe+3 निकलेगा and endogenous production of carbon monoxide occurs to form the biliverdine, which is green colored. Oxygen acts on the alpha-methynyl bridges to form the linear pyrrole. Now biliverdine reductase acts, which is present in the cytosol. यहाँ पे alpha-methynyl bridges is converted to methylene bridges, and formation of a yellow-colored bilirubin, unconjugated bilirubin, is formed here, which is toxic and insoluble. Albumin helps in the transport of bilirubin to liver. Albumin-bilirubin complex बनता है and it is transported to liver. Now, bilirubin metabolism in the liver, uptake by the hepatocytes, conjugation, and then secreted into the bile. In the uptake, the albumin is released and the bilirubin with the help of facilitated diffusion, which is not a rate limiting, जितना आएगा उतना जाएगा अंदर. इसमें दो proteins होती हैं, ligandine and protein Y, which prevents the efflux of bilirubin and keeps the bilirubin in solubilized state. Second is the conjugation with the help of UDP glucuronide transferase. UDP glucuronate add होता है और bilirubin monoglucuronate बनता है. And then again UDP glucuronide transferase acts, UDP glucuronate लगेगा and bilirubin डाइग्लूकुरोनेट बनेगा जो कि कॉन्जुगेटेड बिलिरुबिन है. ये सिक्रीट होगा बाइल में, इंटेस्टाइन में चला जाएगा, but some part with the help of multi-drug resistant protein 3 it enters into the enterohepatic circulation, and some part with the organic anion transport between 1A1 and 1A3 is reuptake by the hepatocytes. Secretion is occurring by the active transport by the multi-drug resistant protein 2, and it is a rate limiting step. Conjugated bilirubin, multi-drug resistant protein 2, active transport, rate limiting, ये हो जाएगा बाइल में चला जाएगा. From there to ileum and colon, where it is converted to urobilinogen. 90% is converted to stercobilin fecus में brown color, and urobilinogen converted to urobilin, remaining part, and gives the yellow color in urine. If there is a complete absence of UDP glucuronide transferase, it occurs the Crigler-Najjar 1 syndrome, and if there is a partial absence, it occurs the Crigler-Najjar 2 syndrome है. अगर यहाँ पे ऑर्गेनिक एनायन ट्रांसपोर्ट प्रोटीन 1A1 या 1A3 का एब्सेंस है, वी हैव द रोटर्स सिंड्रोम, और अगर मल्टी ड्रग रेजिस्टेंट प्रोटीन 2 का एब्सेंस है, वी हैव द Dubin-Johnson's syndrome. So thank you. This was all about the bilirubin metabolism. Thank you very much.